Okay, it's Monday, December 2nd. We've got 23 days of Christmas. Get your list, get all you food, whatever specials, somebody, someone's family members, whatnot. Get you gift ideas in order. Okay, so that's your reminder. Now, what we're going to do this week is sum and difference formulas for trig. Okay, so you come across having to evaluate trig functions for either degrees or radians that you might not have on the unit circle. Okay, so we're going to use the unit circle to do this stuff. Okay, so we've got sine, cosine, and tangent. We have an addition, expansion, and a difference or subtraction expansion, right? Y'all remember back in algebra 2 when you did logs, where you expanded logs or condensed logs? Y'all remember that? Way back when? No? Y'all don't remember that? It's been a day y'all slept on it. So, yeah. All right, so we've got them for each one. All right? So, you need to find your unit circle. It should be either on a white piece of paper or neon yellow. Because that's what you're going to need to have besides this formula right here to be able to work the problem. Okay, while you're doing that, I'm going to go to the next slide.
I know
No, you always use the unit circle. You just gave it away to somebody. Okay.
I was on my folder because I was like, never. I guess I'm wrong, so I don't know what.
All right. What triangles are used to form the unit circle? Y'all remember that? What triangles are used to form or fill out the whole unit circle? We covered them back on one day, way back when. 45, 45, 90, and a 30, 60, what? 90, right? Y'all remember that? That's how all of these on the unit circle, these ordered pairs are used, right? Square root 3, 2s, and all that stuff, right? So here's what the benefit of the sum and difference formulas can do for you. Sine of pi over 12, right? Well, you got to evaluate that by hand. So what you need to do, and what you need to understand is, you've got to find. And what we'll do is we'll keep it simplified down to 30, 60, 90, and 45, 45. Combinations of those to be able to get to the degrees or radians that we need. Okay? So in honors class, they're doing sine of pi over 12, right? For us, this is what we're going to do. I'll show you, I will provide you with this. A substitute. Does that make sense? Pi over 12 is really pi over 3 minus pi over 4. If you think about that and find common denominators, which would be 12, you'd have 4 twelfths minus 3 twelfths, right? If you do that, that would leave you with pi over 12, correct? So all of this now becomes sine of pi over 3 minus pi over 4. Okay? Why is it minus? Because in order to get pi over 12 is pi over 3 minus pi over 4. So I'm going to give you this, right? I'm going to give you the 2 that it needs to be. You're not going to have to go and find those. Fair enough? Now, this becomes your U and this becomes your V. If you look back on your formulas, we're looking at a sign difference, right? Not a sign addition, a sign difference, a subtraction, correct? So tell me the formula or the expansion of that using the sign difference. Okay, what is it? Sine U cosine who? V minus cosine U? Is it cosine?
Mm-hmm.
Cosine U sine V. Fair enough? Okay, so here's what I need for you to do. Okay, do y'all understand how I got the red? Anybody confused about how I got the red? The first things that we wrote down were 6 formulas, right? You had a sign where it had 2 things being added or 2 things being subtracted, correct? Cosine, same thing, and tangent, same thing. So we're looking at sine of pi over 12. I'm going to tell you that's really pi over 3 minus pi over 4. Fair enough? So that's my u minus v. And that's what I put, u minus v, right? And if you substitute those things in for these, then we can do something with it. So what I need for you to do is take about 30 seconds. I need you to take the u, pi over 3, and put it in place of the u down there. The v, which is pi over 4, put it in place of the v there. Okay? So I need you to substitute those. You got 30 seconds. Go. All right. So what did you get right here? You should have got sine pi over 3 cosine pi over who? Minus cosine pi over 3 sine pi over who? All right. Anybody not get that? Y'all didn't get that? Because y'all didn't write that down. That's why y'all didn't get that. Yes.
It doesn't matter which you do.
Shot who?
It doesn't matter which goes first. Sign goes first.
All right. Right here? No. But here and there? Yes. Yeah.
Will we ever need a calculator ever again?
Yeah. All right. But I just write it what you got and you ain't got to worry about anything. If you start thinking, you know, I got to switch things, you'll mess it up. So you will have the formulas, right? Y'all understand that? Formulas you'll have. All you got to do is just substitute stuff in. Now, everybody get the green? Okay. On your unit circle here, you've got ordered pairs, right? Correct? Ordered pairs. Which value of the trig function is the x? What is it? What is it? Come on. Is it sine or cosine or tangent? Are you sure?
Yes.
You positive? 100%?
Yes.
Okay, good. The x is cosine, and the y is the who? Sine. So on this sheet right up here, up above here, this is what I'd do if I were you. I'd put a, where did I get that from? Well, we did evaluating trig functions back way back when, about maybe I don't know, about a month ago. Yeah, remember that? So I would do this. I would write cosine, comma, sine. Then above it, I'd go x and what? Y. Does that make sense? I put that on my unit circle. Here's why, because you want to use that. Okay? So on that unit circle, do you see a pi over 3 and a pi over 4? Yes or no? Yeah, you do. Yeah. All right, so if I want the sine of pi over 3, go find its value. Didn't you do that? What's the value of sine pi over 3?
Square root of 3 over 2.
It's what now?
Square root of 3 over 2.
Yep, that's square root of 3 over what?
2.
All right. Then you got to do the same thing for what? Cosine of pi over 4 minus that. So go ahead and find those values. I'll give you 30 seconds to find those values, right? And substitute them in. And then clean it up and tell me what you got.
Have you ever been to the north?
Me? No, I ain't never been up there. Okay, y'all ready? Yes.
You want to go to the north?
No. All right, what's cosine of pi over 4? Square root of 2 over what?
2.
Right? And what about this one? Square root of 3? No, 1/2?
Oh.
1/2. And this is square root of 2 over what? 2. Did you get what I got?
Yeah.
All right, did you simplify it down?
No,
Why not?
because you started talking about.
Oh, yeah. We chasing rabbits, Mr. Palmer. Okay. Yeah. All right, so if I multiply this, the square root of 6 over 4 minus the square root of 2 over what? 4, right? right?
Seems legit.
So that all combines down to square root of 6 minus square root of 2 over who? 4, correct? I can't combine square root of 6, square root of 2, why? Because they're not like radicals. And yes, that radical is simplified, right? Now, I want you to look at those ordered pairs on that unit circle. I can't reduce anymore. Square root of 6, the only perfect square, well, there's no perfect square to 4 and 6. No. No, because the coefficients would be the only thing that I could simplify. And that's 1. Okay, look. Did you get what I got here? Yes? They traditionally, and I said they, traditionally put it over 1 fraction. Gentlemen, focus, please. A lot of chit chat, cut it out. Now, you could leave it like the black there, but normally they put it as the red, as 1 fraction. So, if you were to look at the value of sine of pi over 12, that in red would be its value. If you took square root of 6 minus square root of 2, divided by 4, then that would be the value of the sine of pi over 12. So that's powerful when now you're just not like looking at 36 and 90. Now you look at combinations of those, right? So that's what this addition and sum allows you to do. Allows you to be able to do values of something other than 30, 60, and 90 or 45s. Now, if you look at your unit circle, look at all the denominators for your unit circles in those ordered pairs. Can you tell me what they are? 2. So what do you think your denominator is going to be for these? 4. Because 2 times 2 is what? 4, right? Here, 2 times 2 is 4. 2 times 2 is 4. The denominator for those ordered pairs is going to be 4, right? So that's going to be there. Now, so I want to show you this, because this is worked out. They substituted, and this is what they got, which is the same as what we got, right? Now, these are in radians. Now, you could turn around and do it in degrees, okay? And that's what we're about to do. So before we leave this, any questions about that? They wanted you to evaluate the sine of pi over 12, right? Not going to make you figure out what combination would give you pi over 12. I'm going to give you the combination. Does that make sense? You will have the combination. All right. Now, let's look at it in terms of degrees. Now, we're looking at 45s, 30 and 60s and 90s, right? 45, 45, 90, 30, 60, 90. So think about the combination that you would need in order to get a 75-degree angle. What would you need? A what?
30 and a 45.
A 30 and a 45. Would you add them or subtract? That's right. And if you think about this, so if you added 30 and 45, you get 75, right? But if you subtracted those, you could get what? A 15, right? So you see, you can use a combination of those to find other values that are beneficial for you, circle, for doing the evaluating of a sine. So I'm going to give you that, right? Use the fact that 75 is 30 and 45. So 75 cosine of 75 degrees really becomes who? The cosine of 30 plus 45, right? You've got right here, this 30 is a U, and that 45 is the what? B. Now, can you use your formula, your sum of difference formula, to expand it, to substitute it in, and evaluate it? Can you do that? Yeah? Any questions about what I'm asking you to do?
So why can you only use 30 and 45? Like, why do you
What are the triangles that are? So we're going based off triangles that are used in the unit circle, right? So I need you to expand it out, right? Substitute them in, find the values of each one, and then clean it up. So I'm going to give you About a minute. All right, a minute. Go. Okay. I want to see if y'all were able to do this. Were you able to go cosine 30, cosine 45 minus sine 30, sine 45? Were you able to go and find those values? The cosine of 30 is square root of 3 over 2. The cosine of 45 is square root of 2 over what? 2. The sine of 30 is 1/2, right? And the sine of 45 is square root of 2 over 2. Multiply these together, you get square root of 6 minus square root of 2 all over who?
Okay,
Yeah.
so for the subtraction sign, like, I put that in, I don't know why.
No.
How do you know the difference?
Well, in your formulas, you go to that one, and it's written out this. Cosine U, cosine, I can spell cosine. Cosine B minus sine U sine B. There is. But everything is driven by that right there.
So if it's that, then it's that.
Yeah, I mean, you got this, and you look to the right, and it'll show you, right? See these? Look. Cosine of U plus B is equal to cosine U minus those.
Okay.
There you go. Just because it's a plus here does not mean it's a plus out there.
Okay.
That's why I said you got to go by these, right? Got to write these things down. Okie dokie. All right. Now, do you notice something about this answer?
It's almost identical to the previous.
Oh, no, ma'am. It is identical.
Okay, it is identical.
It is identical to the previous one, right? 75 degrees is the same as pi over 12, right? 75 degrees, same as pi over 12. So we worked the same example, but we done it in radians one time and what in the other time? Degrees, right? Any questions? All right, so I want you to do this one. I don't think I've killed this one, but here we go. All right, work this one. I want you to work this one, and if you're good, and you're feeling good, then I'll turn you loose on the rest. Fair enough? All right, give you, what, a minute, 2? And then I will show you what you need to take a picture of and do. Okay, I'll have it up on canvas, but check your answers right there. Hold up. Yep, there we go. And then I'll have, hold up. Oh. I need you to, listen, take a picture of 13 through 20. 13 through 20. I'll put it up, but you're responsible for 13 through 20. You are to find sine, cosine, and tangent for all 8 of those. So you got each function on every one. That's cray-cray, isn't it? I'll have it up in Canvas, okay? This page will be up in Canvas. You just have to do 13 through 20. Good?